Hi, my name is Safinah Ali, and I will be presenting our work about exploring generative models with middle school students. My co-authors are Daniella DiPaola, Irene Lee, Jenna Hong, and Cynthia Breazeal. And this work was done at MIT Media Lab and MIT STEP Lab and was supported by the National Science Foundation. Advances in generative machine learning techniques such as GANS introduce a new way to create media. These networks are trained on large data sets to generate new data samples that possibly could have been drawn from the original data set. Though GANs are complex technical algorithms, they have real-world implications for younger students. For instance, they can be used to create manipulated faces of people or deepfakes that can in turn lead to the spread of misinformation. These generative media have found their way on social media sites such as TikTok or Instagram, which are frequented by middle school students. In order to be responsible creators and consumers of digital media, it is imperative that students understand how these systems work and their ethical implications. We utilize a learning trajectory to break down the concept of generative machine learning systems in a scaffolded way. Along with technical concepts, our learning trajectory incorporates ethical and societal implications. In our paper, we outline the learning objectives and goals for this learning trajectory, the results from our workshops, and a framework for incorporating societal impact into our learning trajectory. Our learning trajectory was designed for middle school students with no experience with AI or computer science topics and covered 5 key learning goals: the concept of generation, how GANs work, interactive tools that utilize generative models, their benefits and harms, story creation using generative models, and the ethical implications of GANs with a focus on deepfakes. The work was piloted with 72 middle school students in 5th through 9th grade in remote online workshops. Our first activity, called Generated by AI or Not, asked students to classify various pieces of media as generated by AI or by human. Results suggested that students were not aware of the wide breadth of what AI can generate. Students had a particularly difficult time to understand that deepfake images, videos, and text were not generated by humans or were real. This suggests that students have a very limited knowledge of GANs and what they can create and will benefit from the scaffolded approach. The next activity introduces students to the way GANs work. Students play a game in which they represent the generator or the discriminator as the 2 neural networks that make up a GAN. Right after the game, students try out 4 currently available generative tools: This Person Does Not Exist, Sketch RNN, AI News Anchor, and AI Duet. Students are asked to apply what they learned by identifying what the generator is trying to create and what data set the discriminator is using to determine if what is passes as the training sample. They also asked to identify potential benefits and harm of these tools. We found that students had an easier time identifying the generator versus the discriminator, and they were more likely to identify the discriminator correctly for visual GANs. Students were then introduced to the idea of a deepfake and were taught several techniques to try and detect if something was a deepfake or not. They completed a quiz before and after learning these techniques, and there was no significant change in their score. The students learned that deepfakes exist and talk about their role in the spread of misinformation. They had a difficult time detecting them, which highlighted how realistic these generative media are. Finally, at the end of our workshop, students answered questions about how GANs work. While students gained a good understanding of the 2 neural networks in a GAN and how they work, students were unclear about the specific role of a discriminator network, perhaps due to their limited understanding of how neural networks work. Based on our learning from the workshop, we developed a modified learning trajectory that begins with neural networks, ties in ethical reflections to the final creation of the project. This work demonstrates that by designing a learning trajectory to incorporate technical, applied, and ethical learning goals, students develop a sense of not only how technology works, but how it will integrate with society. Like generative models, several AI technologies have societal impact, and not only technical systems, but are also socio-technical systems. We encourage other K-12 AI educators to take a similar multifaceted, non-linear approach to technical education. Thank you.